Okay, I am going to do one of the problems from your exponential growth and decay word problem worksheet. The first one I'm going to do is number 2. It's talking about population of mosquitoes. It says that there are initially 1,000, so that's 1,000 to start. That is time equal to 0. And then after 1 day, there's 1,800. So 1,800 at time equal to 1. First thing it asks us is for an equation that models this growth. So it fits the poked model. That's P of t is P sub 0, which we call P naught, e to the k t. P naught, you should know, is the initial population. The initial population is the population at time equal to 0, so that is 1,000. So I don't have to do any work to get that. P of t, oops, let me erase that. Oop, that's not an eraser. Blue. Okay, P of t is equal to 1,000 e to the kt. Now I need to find k. And I'm going to use this right here. I will write that down here. So I'm going to use P of 1 is equal to 1,800. From here, this is the P value. This number 1 is the T value. So I'm going to plug the T in here. I'm going to plug the T in here for time, and the P of t in right here. So 1,800 is going to go on the left side of the equation. 1 is going to go in for the t. What I get, back to blue, is that 1,800 is equal to 1,000 e to the k times 1. It's really bad. K times 1. And the k times 1 is all up in the power for that exponential. So I need to solve for k. There's a little bit of, this next step right here is why we have logarithms. First thing I need to do is divide by 1,000. So over 1,000 over 1,000. That gives me 1.8 equals e to the k. It's k times 1, so I'm just going to write it as k. Notice, e is a number, it's 2 point something, it's on your calculator. I've got k right here. I need to figure out the k. So I've got an e to the power, and I need to figure out what that is. I've got an exponential. I need to undo the exponential, which is the whole motivation for having logs. We have exponential functions. Logs are inverses of exponential functions. So we know that log, scratch work over here, log base e is the same as ln. And this guy, ln, is on the calculator, so we can use it. Which is why this is in base e, because it's a calculator problem and you need to be able to use a calculator to do it. And the calculator only has 2 bases. Anyway, there's multiple ways to think about this. I guess I could potentially show both ways. I'll show the think about it as an inverse way first. I've got e to the k. I want to get to the k. ln and e to the are opposites. They're inverses. So I'm going to ln both sides. That gives me ln of 1.8 equals ln of e to the k. This stuff is confusing at first. The left side's easy, you just use a calculator. And the right side, the ln and the e to the are opposites. So the ln and the e to the cancel. What's in the e to the? It is a k. So on the right hand side I have a k. For example, if I asked you to simplify ln of e to the 3t plus 4, this ln and this e to the cancel each other out and leave me with what's left over in there, because those two functions are inverses, so that just gives me 3t plus 4. The other way to do it is to use a basic log conversion, and but I would rather you understand it like this, so I'm not actually going to do the other way. So, I get k is equal to ln of 1.8. Now I get my calculator out, type it in. It gives me k is equal to 0.588. That's rounded. My suggestion is to store that variable on your calculator and use it from here on out. So let me go back up really quickly. Remember, I am using the poked equation. I know that P naught, P sub 0 is 1,000. I wanted to find k. I found k was 0.588. So now I actually have a function for p that only involves t. Remember, e is a number. It's like pi. Alright, so I use this k here. P of t is equal to 1,000 e to the 0.588 t. Alright, so that's part A. So I will circle it in red. Part A. Part A said, find an equation that models its growth. Boom, equation that models its growth. Part A. Okay, now I'm going to do part B. Part B is really, really easy. Part B. Where are we? What's another size of the colony after 3 days? So, days is time. I want to find P of 3. That's my input, 3. So it's 1,000 e to the 0.588 times 3. Now, that's what I'm writing. My suggestion is that you have that 0.588 stored in your calculator, and you type it in to your calculator using that stored variable. If you do it that way, you get 5,832. So 5,832. Boom. That is the answer to B. Part C. Not a space, but that's okay because I was going to stop anyway. Part C. It asks you when, for what P, so how long until there are 1,000 mosquitoes. So it's asking P of question mark equals 1,000. I'm not going to do it, but I will tell you the answer. Hopefully you can get to this answer on your own. This is using the stored variable. I get 3.916 days. That's rounded here, but using the stored variable in the calculator to get to it. So I will circle our answers. That's the answer for B. And that is the answer for C.